Hello all. Today we are solving LeetCode problem number 874, walking robot simulation. So we are given a robot on an infinite XY plane starting at the starting position as 0 0 facing north. So north is this direction and south will be this, and east and west, right? So south, east, west. So the robot receives an array of integer which is named as commands, which represents the sequence of moves that is needed to execute the walking of the robot. So there are only three possible types of instruction given. So which means you have -2, it turns left 90 degree, which means west it turns 90 degree, right? And we can have it as left because this will confuse actually if we are processing in the plane. So -1 indicates right 90 degree, and anywhere from 1 to 9, the k value, if it is lying within 1 to 9 inclusive, we move k units one at a time in that particular direction wherever we are facing actually. So some of the grid of squares are called as obstacles. So the ith obstacle is at a grid point, obstacle of I, xi, yi. So what exactly this indicates is there will be a coordinates which is xi and yi, and this is an obstacle which indicates an obstacle. So if a robot runs into an obstacle, it stays in its current location. So we are moving one by one unit at a time, right? So when we are facing an obstacle, it stays in the previous position. So that is what it is given. It will stay at a current location and move on to the next command. So it stays at the current position, and based on the next command it moves actually. So now return maximum squared Euclidean distance that the robot reaches at any point in its path. So what exactly is a Euclidean distance? So wherever we are at the current position, right? So we can find the Euclidean distance using this formula called as x square and plus y square. So this will be the Euclidean distance formula. So this is what you have to use to calculate the distance finally after when you are done with the the final comments. So this is all about the question. So let us understand this question with the help of example 1. So this is the given commands array and this is the obstacle which is being given. So this should be like this because this array will has a nested tuples which will indicate the coordinates basically, and the output expected here is to be 20. So now standing at this position, so also we have to note we have to return the maximum Euclidean position actually. It's not the last Euclidean position actually. So since it is maximum, so if we are performing only one action at a time, now we have to calculate the Euclidean distance, and if it is a maximum we track it down and then we return it. So initial position is 0 0 and towards north, so it moves upwards. So it will be moving upwards. So first is 4, so we move 4 unit up. So 1 2 3 and 4. So now since we moved 4, this position will be 0 and 4, and so now we are finding the Euclidean distance, which is 0 square plus 4 square, which is equal to 16. So we have the 16, we track it down, and now we are facing -1. So -1 indicates turn right 90 degrees, right? So turn right, so we have to move this direction. So now we have turned, so encountering the next command which is 3, so which is +3, so we have to move 3 units in the current direction. So current direction is right, so we can move one. Let me change the color. So we can move 1 2 3. So this position we have to if you are looking into it, this would be 3 and 4, right? 3 4. So now we can directly calculate it by 3 square plus 4 square, 3 square plus 4 square, which gives 25. But we have to carefully check because the obstacle is in 3 4 position, so which is exactly at this position. So we have to stop at this position, which is nothing but uh, the x-axis for this will be 2, so 2 and 4. So actually this would not be the actual calculated result or Euclidean distance which we need to calculate. Instead this would be 2 square plus 4 square, which is nothing but 4 plus 16 implies 20. So you get 20 as the answer, and this is the maximum than 16, so you replace this with the 16, and now you are checking here there is no more comments, so this will be the final output, and now you return the final output as 20, which is exactly the output which is given in the example. So this is all about the problem. So how do we solve this actually? So what we can do is we can similarly simulate the same thing. So if you are at a position, and for example if you are moving towards north, and if you are encountering -1 or -2, so if it is -1 you can turn left, right? And if it is -2 you can turn, I think this is right and this is left, right? Let me check it. So yeah, so you can turn left. But if you are moving, if south, if you are moving towards south, initial direction is south, so if you are encountering -1, so what happens is towards south, if you are looking into this will be the opposite direction exact to this, right? So then you will move the according to from south, this will be actually right, but looking at the center point, this looks like you have to move left, right? So this changes, and or if it is -2 you move right, so this changes for these two directions. And if you're looking from west and if you're looking from east as well, it changes based on its own perspective, right? So you will handle all these things, and to handle the obstacle, we can use a hash set and store the coordinates as tuple, and then you can track down x and y coordinates starting from 0. So if you're moving up by unit, you can like you will have x and y as 0 and 0 initially. So when you are moving up, you can increment x by 1 and y also by 1 based on directions. Following the simulation, and then wherever if you are encountering, if you have to check if you are encountering that particular value, for example you have x equal to 1 and y equal to 0 at the first iteration, which is 1 0, and you have to check if 1 0 is present in the hash set. If yes, what you can do is you can stay at the before position, right, the past position, and you in this way you can handle the obstacle as well. So this problem is pretty straightforward. It is just the simulation which we have to handle it, and with this we can solve the problem with the simulation idea. So the time complexity which we will take to solve this particular problem is big O of n plus m, so where n indicates the length of comments and m indicates the number of obstacles. So yeah, so with this idea, let us go ahead and code this up. So first, as I said, we have to handle the obstacle, so we will have a set. So obstacle is equal to set, so this will be the initial set value, I mean initialized set, and now we have to fill in with the tuples. So for x y in obstacles, yes, you will add you have to add it in the tuple format. So x and y, you are adding it into the set, and now this is done. And now you will have the initial direction d as north, and now the initial coordinate value x and y is equal to 0, 0. So this will be the value, and max distance is also equal to 0. So all these initial value is done. So now we will operate based on comments. So for comments in comments, okay, so now if comment A is equal to -1, and we will have else elif comment is equal to -2. So you have these two comments, and then else you have the other part which ranges from the positive 1 to positive 9, right? So this is how you will handle this. So I will have it as pass for this, and now we will fill with this actually. So now if direction is equal to north, right? So if it is equal to north, then what happens is you will have to update the new updated direction to be west, right? So because from north, if it is -1, we move. If it is -1, we turn right degree, right 90 degree right. So this will be west. Yeah, this should be east. I'm so sorry about that. So you will update d is equal to east, right? And the other direction, so elif if d is west, so if it is west, then what happens is tilting towards 90 degree towards right, you will get if it is west, you will get north. Yeah, so d should be north. So I'm just confused about this actually. So elif, then d is equal to, I think I can go to the easiest one, which is south. So south you'll get west. So south d is equal to west, and else you have d is equal to east, north, west, and south. So yeah, all directions are here, so it's clear. So now this is done. So for this part as also we have to handle it. So if d is equal to yeah, I have missed this. If it is equal to north, then what happens is this moves to left. If it is east here, so then this should be west. So is equal to west, and elif d is equal to west here. Then what happens is this becomes south, right? Yeah, north, this should become south. So west, what happens is d is equal to south, and elif d is equal to now it's south. So if it is south, this becomes west, and opposite is equal to east, right? And else d is equal to we missed north. Yep, this is north. So now this is done. So there comes the next part, handling the length actually. So now if the character no, the direction is equal to north, then what happens is we have to iterate, and then we will check if there is some obstacle. If obstacle, we break it and we return the previous y and x values accordingly. So for this, if it is north, then we have to worry about y coordinate, and if it is south also, we have to worry about y coordinate. If it is west and east, we have to worry about the x coordinates. So now So for I in range, we run till command times, because that is how we determine the units. So if x and y plus 1 in obstacle, then what happens is we break, and else what happens is we increment y, because we are moving by 1 unit, right? And now let me copy this. So this will be same, but for south we have to decrement. So if d is, no, this should be lf d is equal to this should be equal to, if it is equal to south, then what happens is, yes, so now we will be decrementing because we are moving in the negative coordinate, right? So this should be decremented by 1. So now this is done. So now we are moving to lf t is equal to west. So in this case what happens is we have to worry about the x coordinate value. So again we iterate. So for I in range, command times, and if x, this is x plus 1, so x plus 1, west is, yeah, no, east is plus 1, west should be minus 1, yes. So x and y in obstacle, then what happens is you break, else you decrement x because of the negative coordinate by 1, right? So the last part, let me copy it. Else what happens is you increment, and you increment by 1, and now this is done. So you will calculate the maximum distance now, because you are done with one particular command, and you have the x and y coordinate value handy with you. So now we will calculate the distance. So maximum distance, so we have a variable named as maximum distance is equal to max of maximum distance and y power multiplied with, because of square, so it's easy, right? So with y. So now this is done. So you will update the maximum value, and finally you can return maximum value. So we came out of the row, return max dist. So that is it. Let us run it and submit it, and there you go. Thank you.